Okay, our next two sample problems start pulling it all together. We start putting in chapter 2 information where you need to know how to name things and write a correct chemical formula from a name. We need to know how to balance chemical equations, and we need to know how to do stoichiometry with them. But remember, kind of part of this chapter was realizing that when we have a chemical equation that involves gases, we can use PV equals nRT to allow us to get the number of moles of gas that are involved in our chemical reaction. So let's see if we can apply that to this problem here. Engineers use copper in absorbent beds to react with and remove oxygen impurities in ethylene used to make polyethylene. Again, not important to the problem, just gives you some context. The beds are regenerated when hot hydrogen reduces the copper 2 oxide, forming the pure metal and water. So that's important because that's where we're going to get our chemical equation from. On a laboratory scale, we want to know what volume of hydrogen gas at 765 torr and 225 degrees C is needed to reduce 35.5 grams of copper 2 oxide. All right, so a lot of words there. Let's take this and see if we can break it apart, writing down information we know, where we want to go, and kind of break this problem down. Okay, let's first take a piece of information that we know is the chemical equation that they give to us in words. All right, so we're going to have hot hydrogen gas reduces copper 2 oxide. So copper 2 oxide is CuO. And we make the pure metal and then H2O. Since we're doing this hot, we're going to assume that we've got water vapor there, H2O gas. Our chemical equation is actually balanced as is, so we don't have to do anything with balancing it. Again, if you had the wrong information for copper 2 oxide and maybe had Cu2O or CuO2, you'd have to go ahead and balance this equation, and that would, set everything off here because we wouldn't have the right information here. All right, so we know that that's our balanced chemical equation. The question asks us, on a laboratory scale, what volume of hydrogen gas? So what volume of hydrogen gas? So we'd like to know the volume of hydrogen gas here. So we want to know the volume of hydrogen gas. So is going to, what volume of hydrogen gas at 765 torr and 225 C is needed to reduce 35.5 grams of copper 2 oxide. All right, so again, putting information I know, and when I have a chemical equation, I like to write information down here. So we've got 35.5 grams of our copper 2 oxide, and we'd like to know what volume of hydrogen gas are we going to need when we have a pressure that's equal to 765 torr and then a temperature that's equal to 225 degrees C. So it looks like we've got two reagents that are reacting with one another to make products. So we know how much of this one we have, and we'd like to know how much of this one we need to react. Well, in order to talk about who's reacting, we need to have each of these in terms of moles. So if we'd like to get to moles of this, we can easily do mass to moles using molar mass. Well, again, we need to know moles of this guy. Well, since this is a gas, again, if we know the information that allow us to get to moles, again, we can figure out the volume here. So this is, the volume is, excuse me for a second there, the volume is what we needed to get to. So we can walk here from mass of copper oxide using molecular weight to moles. We can use a balanced chemical equation to change who we're talking about. And I should have that this arrow is going to go in the other direction because we're going to use PV equals nRT to, again, moles is going to be given from our balanced chemical equation. We know the pressure and temperature of the gas, so then we're going to be solving for our volume. Apologies there, I was kind of trying to take this in two directions there. We're going to take information that we're given from our mass of one of our reagents. Molecular weight will get us to moles. Our balanced chemical equation will get to moles of H2, and then PV equals nRT can get us to the volume of gas that we need. So that's our walk that we're going to have, so let's just go ahead and do it. So we've got 35.5 grams of copper oxide. Molar mass says that 1 mole of copper oxide is going to be 79.55 grams of copper oxide. 1 mole of copper oxide will react with 1 mole of hydrogen gas. And so that tells us that we need to have 0.446 moles of hydrogen gas. Solving PV equals nRT for volume, volume is equal to nRT over P. Again, we need to make sure that our variables here are in the correct units. So pressure, we're going to need to divide by 760 torr to get it into atmospheres. Okay, and that's going to give us 1.01 atmosphere. We have just a little bit greater than 1 atmosphere. So 1.01 atmosphere. Temperature, 225 C, we need to get that to Kelvin, so we add 273 and we get 498 Kelvin. Now I'm ready to put everything into this equation. We've got 0.446 moles. R is 0.08206 liter atmosphere per mole Kelvin. Temperature is again 498 Kelvin. Divide that by our pressure, which is 1.01 atmosphere. Atmosphere cancel. Kelvin cancel. Moles cancel, and we're left with units that we want, which is in liters. So volume is we're going to need 18.1 liters of hydrogen gas.